Good afternoon, Dr. Dong Ebo. This is Raymond Amanyire, Bachelor of Science in Software Engineering, Year 2. As per the COVID coursework about data communication, this is my submission. I will start with number 3, which was about satellites, which I define satellites are the components that provide communication from one point of the Earth to another. It may include an earth station or a node or an end-user terminal or a telephone. However, we have 3 categories of satellites. They are categorized according based on the location of the orbit, and this includes your stationary Earth orbit, the middle Earth orbit, and low Earth orbit. Starting with geostationary Earth orbit, they are located at an altitude of 35,786 kilometers above the Earth, and they have one orbit. They are located above the upper Van Allen belt, and in this case, the Van Allen belt is defined as a layer that contains charged particles. Geostationary Earth orbit move at the same speed as the Earth, so it seems, since they move at the same speed with the Earth, it is fixed above a certain point, about a certain point. Next, we have the middle Earth orbit, which is located at an altitude of between 5,000 to 15,000 kilometers above the surface. They are located above the lower Van Allen belt and below the upper Van Allen belt, which means they are located between the Van Allen belts, the lower and the upper one. Middle Earth orbits, they take 6 to 8 hours to circle the Earth. An example includes the global positioning system, or the GPS, which is used in the US military. And the last one, we have the lower Earth orbit, which is located at an altitude of below 2,000 kilometers. The lower Earth orbit is located below the lower Van Allen belt, and it has a speed of about 20,000 to 25,000 kilometers per hour, with a rotational speed or rotational period of 90 to 120 minutes. And the first broadband lower Earth orbit system was the geodesic. Thanks so much. Yes, then on number 2, we had to touch some concepts about multiplexing, and there I would start with frequency division multiplexing, which definite analog technique that can be applied when the bandwidth of a link is greater than the combined bandwidth of the signals to be transmitted. In FDM, signals generated by sending each device modulate different carrier frequencies. The channel through which the various signals travel are separated by the strips of unused bandwidth. They are called guard bands, and this is to prevent the signals from overlapping, the signals of in the link which are going to be transmitted from overlapping. And that's all about FDM, or frequency division multiplexing. Then on the concept number 2 of wavelength division multiplexing, it's also analog. It's an analog multiplexing technique to combine optical to combine optical signals. It's designed to use high data rate capability of the fiber optical cable. Since the optical fiber data rate is higher than the rate of metallic transmission cable, thus using a fiber optic cable for a one single transmission wastes their variable bandwidth, and in that, multiplexing allows to combine several lines into one. And the third concept was about the synchronous time division multiplexing. Time division multiplexing generally is a digital multiplexing technique for combining several low rate channels into a high rate one. Basically, with a synchronous TDM, synchronous TDM is one of the parts of the TDM, and basically each input connection has an altimeter in the output, even if it's not sending data. So which means even if it's not sending data, the input connection has that kind of an ultimate. Then another concept was about interleaving. Interleaving, basically, it's in the time division multiplexing. It's a process whereby switch opens in front a connection, while also about multiplexing, and that connection has an opportunity to send a unit into the path. Like I said, it happens in the TDM because it can be visualized as a two fast rotating fast rotating switches. That's the one for multiplexing and the one for demultiplexing. Basically, interleaving, it both happens in multiplexing and the demultiplexing. So that's why it have two different switches. Then the last concept was about frequency hopping spread spectrum, which is FHSS, which is basically a technique by which uses m different carrier frequencies that are modulated by a source signal. At one moment the signal modulates one carrier frequency. At the next moment the signal modulates another carrier frequency. Basically, it's also to where, like, at one moment it bears the signal modulates at one carrier frequency, and the next one then it modulates another carrier frequency. Basically, it's all about multiplexing, and I think they were 5 concepts, and I think that is it. Thank you. Yeah, and on the on number 2, on part 2 rather, we had to explain some concepts, like explain how the multi-carrier modulation scheme known as the orthogonal frequency multiplexing works. Generally, this method for signal generation, it's a method for signal for signal generation in a 5G has ISM band. It's similar like FDM, like frequency division multiplexing, but with the major difference is that the subbands are used by one source at a given time, at one time. So it uses the phase shift keying and quadrature amplifier modulation, QAM, PScan QAM for modulation, and the bands, the band to be transferred is divided into 52 subbands with 48 subbands for sending 48 groups of bits at a time, and 4 subbands for control information. Generally, that's how it works. And we divide the band into subbands because it diminishes the effect of interference. Dividing the band into subbands diminishes the effect of interference. Of course, interference comes with, because you're transferring with dividing the band into subbands to affect interference. Yeah, and if the subbands are used randomly, security can also be increased. So we divide into subbands to limit interference and some to increase security. That's basically how multi-carrier modulation scheme for OFM works. Then our part B was what's meant by intersignal interference and how it arises. It's one of the basically intersignal interference. It's caused by multiple path propagation, in which a wireless signal from a transmitter reaches the receiver via multiple paths. Basically, the multi-path propagation from where a signal from a transmitter reaches the receiver via multiple paths is kind of interference, which means they further distort the amplitude or maybe or the phase of the signal. That's by causing further interference with the received signal. Yeah, that's basically also with intersignal interference. Then the last one was part C, which was differentiate between uniform and non-uniform quantization. From here, I think there are all types of quantization, and I think the only difference is that in uniform quantization, the levels are in from a space. So maybe are in from a space. So maybe there is equal step size, like the levels of the cells in the uniform quantization. They are equally or uniform spaced, and there's an equal step size. And where in non-uniform, it's the opposite, of course, because there's an equal spacing, and mostly the relation between them is logarithmic. That's basically with uniform and non-uniform quantization. Otherwise, thanks so much for having introduced to us data communication. It's a very interesting course. We found it very interesting. We've learned so many things, multiplexing, related to serialized unit telephony. It's been very interesting. Thanks so much. Be blessed. Thank you so much. Bye.